Hello and welcome to The Most Significant Bit, a podcast that explores the connections between engineering, technology, humanities, and the arts. I'm Herringbone, and today we're discussing how the mantis shrimp's unique herringbone structure is inspiring the next generation of impact-resistant materials. In today's episode, we will discuss how engineers have been inspired by a tiny marine creature for developing more robust and resilient materials. Our discussion will be on the mantis shrimp and the fascinating herringbone pattern on its amazing club. This is a case of biomimicry, where engineers look to nature to find solutions for their problems. We will explore how scientists came across the herringbone pattern in the mantis shrimp and what makes them believe that it is so efficient, and how it might be applied in products in the future. Let's begin with the history of this research. It is commonly known that the mantis shrimp is able to hit its prey at incredibly fast speeds. Despite being no larger than several inches in length, the mantis shrimp is capable of smashing hard shells without getting its club broken. The question which scientists have been facing was obvious. How does such a small creature withstand such repetitive blows? In their experiments with the inner structure of the mantis shrimp's club, the scientists from Purdue University and the University of California used advanced techniques of imaging. They managed to discover a unique herringbone pattern consisting of fibers spreading impact stresses across the whole structure. The pattern diverts the stress path and slows down the development of cracks inside the club, making it able to withstand repetitive impacts. What's worth mentioning is that the strength of the mantis shrimp's club wasn't provided by the materials themselves, but by the pattern in which they were arranged. After the discovery of the working principle behind the structure, researchers became interested in finding out whether they could replicate it. By using techniques such as 3D printing, engineers have created materials that had similar patterns on the inside and have experimented with them. Initial findings revealed that the new materials not only weighed less, but were also better at withstanding impacts than most traditional composites. The pattern made it easier for the force to be distributed across itself and prevented cracks from spreading further. Nevertheless, the research is in its initial phase. Researchers are currently experimenting with various patterns and how to manufacture them, and their practical application has yet to be determined. Given the relatively nascent nature of this research, there aren't many commercially available products that are using this design concept yet. I would say it is hard to tell which firms are most likely to utilize it. Nonetheless, the research indicates that there is potential for adoption within a number of industries. First of all, the aerospace industry needs lightweight materials that are also durable in order to maximize fuel efficiency. There is also potential for automotive manufacturers to apply this technology and benefit from increased passenger safety without any additional weight. Defense industry will definitely be interested in it given the applications in protective gear, and sporting goods manufacturers will use it in helmets and other shock-resistant goods. The main reason why I find it intriguing is that it is an example of how engineering does not necessarily involve invention, but rather observation and analysis of how certain objects operate. While it could take many years for this to translate into commercial products, the research has already started to change the way engineers design materials. In addition to considering the makeup of the material itself, they are also considering how they might arrange the material to perform better. Today we discussed the methods by which the mantis shrimp's herringbone structure was discovered and its capability to withstand impacts and crack formation. and its potential application to new engineering materials. While the technology is fairly new, it shows us how observing the world around us helps find solutions to practical engineering problems. One lesson I learned through the course of this project is that the best engineering solutions can sometimes be found through the study of nature. Thank you very much, and all the best to everyone in the future.